Hello. Welcome to our talk named Identifying Heavy Flavor Jets Using Vectors of Locally Aggregated Descriptors. In the context of heavy ion collisions, a signature phenomenon called jet quenching occurs wherein jet loses energy and ends up modified due to the quark gluon plasma. By measuring the substructure of jets tagged as originating from heavy flavor quarks, or jets containing heavy flavor mesons, we can study the mass dependence on the jet-medium interactions. But such measurements are statistically hungry, and classical approaches to heavy flavor jet reconstruction might lead to inefficient use of available data, which calls for more sophisticated approaches. In the figure below you can see a ratio of parton radiator energy versus emission opening angle distribution of bottom quarks to light partons. The blue region, which corresponds to small opening angles, shows suppression for bottom quarks, which is a signature of dead cone effect. To solve this task we introduce a jet VLAD, a novel set-based machine learning tagging approach that builds upon net VLAD layer. In this paradigm we treat event as a set of particle state vectors, and jet as a subset of such event. Our approach considers only low-level input information related to tracking, transverse momentum, pseudo-rapidity, azimuthal angle, and vertexing, distances of closest approach to primary vertex in X, Y, and Z planes. We optimize model hyperparameters, depth d, and the number of net VLAD cluster NC by the means of random grid search. The optimal hyperparameters are validated by scan, which is fixing one variable and varying another. For every configuration we train 3 models to obtain statistical uncertainties that arise due to the random nature of neural network initialization. On this slide you can see the main result of our approach, jet PT dependent rejection and purity graphs. To the left you can see signal purity versus signal efficiency graph for various jet transverse momenta. To the right you can see background rejection versus signal efficiency graph for various jet transverse momenta. This shows that approach achieves good performance across different PT ranges at RHIC energies down to the lowest PT. We also estimate uncertainties which are coming from the model. Those are denoted by color bands around the curves. As a conclusion, we propose a novel set-based tagging method based on the net VLAD layer. Our approach achieves approximately 80% purity, 80% efficiency, and rejection factor of 200 from low to high PT, which enables an efficient searches for signatures of heavy flavor jet radiation patterns. Our approach is general and can be applied to many other tasks such as jet similarity search, photon pi-zero discrimination, and so on. Our next goal is to build the self-supervised or unsupervised jet event feature space for fast similarity search of events and jets. If you are interested in applying our approach, please visit the GitHub link down below where you can find implementation of our method. Thank you for your attention.